Hello, welcome to binary search tree interview, real interview question in C#. Remember, this is a real interview question. This is actually the question that you are going to be tested on, not assumed question. I'll make no mistake about it. This is the real interview question you are going to face out there. It's a secret I'm revealing to you, although I shouldn't do that, but I think it should be easier for you. I'm Kindson the Genius with over 18 years of skills and experience in computer programming, web development, and as a software engineer. Remember, click on subscribe button down below so that you subscribe to get more answers to interview questions. Now, this is the interview question. It says binary search tree. Okay, this is a little explanation. Write a function that checks if a given binary search tree contains a value. For example, the following tree: n1 value 1 left and null, n2 value left, n1 right null, value 3 left null right null. Call contains n2 3 and it should return true since a tree with root at n2 contains 3, the number 3. Alright, so we are going to write a function that searches for an item in a binary search tree. So I'm going to open the particular website that contains the questions you are going to be tested on. So if you go to testdome.com, www.testdome.com, go to questions. This is actually what you are going to use if you face an interview. If you go to C#, you can see the second question, binary search tree. It is rendered as easy here, but if you can see, many people fail it. Large number of people fail it, so it's not really easy, I must tell you that. So let's open and solve it. The interesting thing about this test website is that you get your result immediately as if you solve it correctly. Alright, so now let's solve it. We'll time ourselves. They gave us 15 minutes, as you can see, 15 minutes, but many people fail it, so it's not easy as they say, it's actually hard. Alright, so here you remove this row, right, delete it. That's where you are going to write your program. Alright, so they are saying write a function. Okay, so they already have defined a node for us. Nodes in value left, node right. So let's start. We are starting in 9:56. Let's see how long it will take us to solve this problem. So what you say is if root, because the node you are given is the root, so check the value of that node. If root dot value equal to value, okay, so the first thing you are going to do is to search the root, because the root is the first part of the node of the tree. So if root dot value is equal to value, what we are going to do is to return. It expects us to return what? To return both. Okay, return true. Okay, it means that we found it. We return true. Now let's see if it's not. But we can also, it doesn't also have to be null. So if root dot value is not equal to null and root dot value, okay, well, it's not necessary because already we are checking if it's equal to value. So what if it's not equal to value? If root dot value, if it's not equal to value, uh, then let's see if root dot let's see. Okay, so if root is not equal to, if let's start with the right side, root dot right, so we are trying to check this value. If this value is less than root dot right dot left, okay, if it's less than root, then we place it on the left side. So if value is less than root dot value, okay, and I want to also make sure it's not null, and root is not equal to null. So at this point, if our value is less than root dot value and root dot right, sorry, root dot left is not null. So if the left subtree is not null, okay, and the value is less than root of left, so what we are going to do is to return, because anytime you are using a binary search tree you use recursion, so return contains root dot left and value. Alright, so if value is less than the root value and it has a left subtree, then carry out the same action on the left subtree. Let's do the same. Remember, you need to say else if. So in the other one we search. To save time, let's just copy this and use it for the right subtree. So else if root dot value, if value is greater than, this time let's text for greater than root dot value and root dot right is not null, okay, then return contains root dot right. Okay, it means that you recursively search the right subtree. Well, if root dot value is not equal to value and is not null, and if we don't get any of this, it means that the search have failed. So we simply return false. Okay, so that is what we are going to return. So that is pretty much it. That is the solution. Let's run it anyway to see if we got it correctly. Take some seconds. So it says error expected in line 27. In line 27, let's debug error in line 27. Okay, we need to close this last one, and the same in line 32. We close it also. Is it 32, 31? Okay, so let's run it to see if we got the answer correctly. See, your score is 100% perfect. So that is how to search a binary tree. How many minutes did it take us? We started at 9:56 and now it's 10:02, meaning that it took us I think 6 minutes to solve. So at least we did so well. I'd like to thank you for watching. If you have any particular question you want me to solve, just put it there in the comment box. Leave it as a comment and I'm going to solve it for you. Also click on subscribe so that you subscribe to my channel so that you get notified when I make new interview questions every time. I remain Kainton the Genius and thank you for watching.